Now, the last thing I asked people to do on the fifth question was write down the definition of change in potential energy. Okay. That definition was given. I stated it in lab. Most people were there, but of course, it's the end of the lab. I got on people a little bit for not remembering it, but I'm trying to make a point that that's really important. Potential energy is a really important quantity. And if I give you a definition of a really important quantity, you should lock it in right away. It's more efficient than trying to lock it in several days later when you have forgotten anything that I would have said if you haven't reviewed your notes. So, they talked about the need to put something like that in your notes, put a big star next to it, list it in a separate page, and spend 30 seconds sometime later that day just looking at those high points, whatever reference you want to give them, so you start remembering what was said. So, it's just a advice on note-taking, advice on keeping track of the things that are said that you think are really important, so you can continue to think about them and try to recreate what was said. Of course, you're going to see it in the videos when they get posted, but you want to keep yourself active by kind of keeping a narrative going somehow in your notes and noting the really big things. Anyhow, I'm not going to tell you what that definition is. Okay, I'm going to tell you. It's equal and opposite to the work done by a conservative force. So if these are conservative forces, you can calculate the work done. The change in the potential energy will be the opposite of that. In other words, in this case, the work done is positive because the area under this curve is clearly positive. So the change in potential energy, if this is a conservative force, is going to be negative. It'll be the negative of your 2.6 joules, or whatever your estimate was. Okay? Over here, looks like the area between the curve and the x-axis, well, the integral of this function is negative. So if this is a conservative force, then the change in potential energy due to this conservative force is going to be positive because the work done is negative. And also, I guess I should say, and I didn't say it carefully enough last time, this is actually negative 15 newtons. So it's really negative 15 newtons times 5 meters, or negative 75 joules. I was hung up on the magnitude and I neglected something really important. So make sure you understand that. And don't make the mistakes that I make.